And it's 8:30 Norwegian time, and I have the pleasure of welcoming you to the Norwegian Society of Maintenance's meeting with Jason Tranter from Mobius Institute. I ask all except Jason Tranter and Tommy Glesnes to please turn off your cameras and microphones. My name is Siri Ulvin, and I'm the head of administration at NFV. NFV is the organization for companies, organizations, and individuals within the subjects industrial maintenance, production processes, and risk management. We offer a number of courses and conferences within our subjects, both world-class maintenance and many shorter courses. Go to nfv.no for more information. Welcome to all the participants here today. This meeting is being recorded, and the recording will be published on nfv.no later. Now I leave the floor to Mr. Tommy Glesnes, Managing Director of AMPS AS.
Thank you, Siri. Good morning and welcome everyone. And special welcome to Jason Tranter, live from Australia, with his shirt open and everything. Yes, I'm Tommy Glesnes, founder and partner of AMPS AS. We are a service and consulting company for condition monitoring and reliability improvements. Jason Tranter is the founder of Mobius Institute. He has personally developed the famous vibration training courses from category 1 to all the way to category 4 with this ISO certification or accreditation as we call it. These courses are famous worldwide, and I think there are no other training courses available with similar training material with the simulators where you can actually look inside the machine, inside the bearing, and you have simulator for all the training topics and so on. So that's excellent. For the last 15 years, Jason and his team at Mobius has developed several concepts and training material within maintenance management, all based on the concept around reliability, which he will talk to us today or teach us today. He has also written 3 books. 1, 2, 3 books. They are all on the topic of how to start a reliability improvement initiative. They are, if you are improving your maintenance program, or if you want a guide to where do I start, where do I go from now, these books could be worth reading. Just a recommendation from my side. For approximately 10 years ago, I also invited Jason to Norway for a seminar which we call Reliability in a Day. With Jason's knowledge, that was a very long day, I can tell you. Now, finally, he's back in Norway, not back, but at least live in Norway to share his knowledge. So I just say fasten your seatbelt and get ready. Here is Jason Tranter.
Well, thank you very much, Tommy, for that introduction. I hope you meant that in a good way, that it was a long day. I know I talk and love to talk and get people to ask questions and everything. And that's certainly an option today. If you think of any questions or you would like to challenge me on any points or anything like that, that's what this is all for, to share ideas and to learn a little bit more. This presentation, as you can hopefully see there on the screen, achieving high reliability, but it's artificial intelligence, Industry 4.0 and PDM, predictive maintenance, versus a structured reliability program. Yeah, these are both really big topics, so I'm going to try to make sure that I'm finished on time and cover all the points. Okay, so there is no doubt that artificial intelligence, machine learning applied to predictive maintenance, applied to the potential of Industry 4.0 represents a huge opportunity for industry. There's a lot of development going on right now. There are a lot of very large companies looking at this opportunity. You know, when I first got involved with condition monitoring and reliability, particularly condition monitoring, seemed like it was a very small world. There were small companies involved, sort of a smaller group of companies developing products and so on. And if you tried to talk to people from larger organizations or talk to people in senior management, generally they didn't know what you're talking about. There was limited interest, and the condition monitoring group was just a group of people hidden down in the bowels of the organization. Now that's all changing. People are seeing the opportunity to apply artificial intelligence to things that we've been doing for a long time. I should say not just artificial intelligence, but the industrial Internet of Things and networking and big data and integrated systems and so on. So the opportunity is to use these smart systems to provide the typical type of condition monitoring warning that there's a problem coming, to automate that process and potentially then integrate it with other systems. So not only maintenance work orders generated, but potentially it can be connected to other machines so that the production process is modified, or spare units can be switched in, and things like that. The opportunity is to have very complex decisions made much more quickly to achieve more optimal results. And I would like to make the point that I think there's a bit of a drive that the less you have to deal with people and their ability to either collect the data or do the analysis, then that has a certain appeal. And certainly the pandemic over the last 18 months plus has sort of sharpened a focus in that area. The more they can operate their plants and operate them effectively without people, the better. So that's the opportunity. It's worth briefly mentioning, though, that I like to say all that glitters is not gold. It looks like a tremendous opportunity, but to actually achieve this level of proficiency so that an organization can put its trust in the decisions that this automated system will come to is quite challenging. Machine learning basically is a process of teaching a sophisticated software program that is basically using statistical analysis to relate, ideally, cause and effect. So if it sees whether it's vibration data or performance data or whatever it is, and it can see how the data changes and it learns what those changes mean, then it can either detect when a condition has changed, anomaly detection, detect that the machine has a problem without necessarily saying what that is, or it can go a step further and actually attempt to diagnose that problem. It's a bearing fault, it's a filter blocked or whatever, and then potentially predict and say, well, this is the remaining useful life. This is when you must take action. And potentially, the promise of Industry 4.0 is really that the system would also be able to act so that the manufacturing process itself will become more intelligent. And part of it is learning the health and operating performance of these physical assets. My experience so far is that there is a little too much hype, meaning promises being made that are not being kept. Because as Tommy mentioned, running a training organization and being known particularly in the vibration circles, but reliability circles, we are sometimes contacted by companies that wish to develop these systems or have developed systems and still have questions. And it is sometimes scary how little knowledge they actually have of industry, of machines, their failure modes. There's a lot of businesses joining that have the technical ability to develop these sorts of systems without knowing a lot about the application and just thinking, oh, the vibration changes, it means the machine's failing. That can't be too hard. And so as a result, and I've also sort of done some research with a lot of companies, asking them about what they're doing, how capable their systems are, what approaches they're taking, and so on. And as I say, there's websites and brochures and marketing messages that sound absolutely wonderful. But when you dig down, you find that it's not all true. I guess is the simple way to put it. The systems are not nearly as capable as they say. Anyway, I don't want to say that the technology can't work or that it's not working in some cases, but I think a lot of people are going to be upset when they invest a great deal of money and find the systems either not working at all, or it's taking their systems a very long time to learn. You know, I mean, if you think about vibration analysis, you have to see a lot of vibration data and therefore a lot of failures before a system can truly learn. There are solutions to everything, but anyway, it's just important to understand. I think for a moment, it's also worth stepping back a little and saying, well, why does any of this exist? And I think right now there's a push with management to take the step forward, to hopefully invest a little money and get much better results. But when they think of improving reliability, it's potentially the reliability and the dependability of the facility as a whole. You know, can they produce product at the low price, at the high volume, keep their customers happy, no injuries, no environmental harm, and so on. So the promise that they could install some sort of computer system with sensors and it would predict equipment failure and help them avoid those failures, you know, is a very attractive proposition. You know, they want dependable operation and therefore from that happy customers. They want higher output, reduced costs, and therefore more profit. They want warnings about future problems, although that's not necessarily what the executives are thinking, but that's how they think they can achieve those first two goals. And they certainly see the opportunity with Industry 4.0 and the digital twin, smart operations, and all the things that I talked about. And as I also mentioned earlier, this idea that, hey, if all of that can happen, and we're not relying on people to have the skills and knowledge and experience to be able to do all those things and make those decisions, then that's also would be a good outcome. I would rather that management looked at this a little differently. And not that senior executives are going to think about those assets, but they need to appreciate the difference between the reliability of the site versus the reliability of the assets and the money and problems that can be avoided when they focus on the reliability of the assets. Because the operation will be even more dependable. They will have happier customers. They will have even higher output, even lower costs, and therefore more profits. The idea is that rather than focusing on achieving warnings about future problems, we would rather that the future problems were rare, that the equipment could just continue to operate reliably, safely. So I would say rather than looking at Industry 4.0, they should as well think about reliability 4.0. I mean, that's just the name I came up with. I don't know whether anyone else uses that term, but you know, thinking that reliable assets is the best path, I think, to Industry 4.0. And you know, let's not try to sort of focus on independence from people. I think people will always be required, especially people who can do the troubleshooting and validate what the automated systems are coming up with and teach those systems and so on. Because ideally, what we would hear from our artificial intelligence / machine learning system is everything's fine. You know, we're not planning to perform some maintenance. We're not looking at any interruption to production. We're not looking at the costs associated with that, the risks associated with that. Hey, the equipment's fine. Now, of course, it's a little too optimistic to talk about equipment never failing, but certainly we should be doing what we can to avoid those avoidable failures. So, if you think about what contributes to reliability, there's certainly right at the beginning, the design and project management process and the procurement process. Are we designing for reliability and safety and availability and so on, or just buying what's the least expensive that meets minimal requirements? Performing quality control, particularly when we purchase the equipment, doing acceptance testing and so on. How we manage the spares can affect reliability. And certainly the whole maintenance process affects reliability. The way we install the equipment, commission the equipment, start up the equipment, shut down the equipment, all affects reliability. The ongoing care, keeping it clean, lubricated, properly adjusted, and so on, all will affect future operations, future reliability. And certainly the way we operate the equipment on a daily basis will all affect. But the question is, will artificial intelligence solve all those problems? It's possible that AI can help solve the operational problems. If a smart system is operating the equipment, then potentially it'll be under less stress. But for the most part, everything else, it's all about humans. It's decisions that humans are making, not appreciating the consequences of the choices they're making. And so we, until we can either greatly aid those humans in their decision-making process or control them, we're always going to have those sources of human error. And that's why a more conventional approach to reliability in combination with artificial intelligence and so on will get organizations the best results. Yep, we can employ robots and technically they won't make human errors, but then again, someone has to program them and teach them and so on. So there's a lot we could talk about in relation to artificial intelligence and how it can be applied to condition monitoring, the technical challenges associated with that. But I think it's worth also saying, what's the alternative and what's the business case for the alternative if you can achieve effective predictive maintenance? And reliability 4.0 is all about improving the future. It's not just seeing the future problems coming. We would rather improve the future, and therefore we're scheduling less outages to deal with the maintenance requirements and so on. So, look, I'm just making this stuff up. You can't look up a journal somewhere and find out what reliability 1.0 looks like. But by my little naming scheme, it's just reactive maintenance. And there's certainly a lot of organizations who are embroiled in reactive maintenance, that equipment fails, they have to deal with it, replace it when it fails, and hopefully be good at replacing it, hopefully be fast at replacing it, but not so fast that you induce more failures. And it's worth saying that companies facing a lot of reactive maintenance, who therefore probably do not have any form of condition monitoring, condition-based maintenance, and so on. For them, the idea of artificial intelligence, machine learning is most appealing, because even if there are flaws in the way one would apply that technology at this time, it's a lot better than nothing. And right now they have nothing. So for them to build the reliability program from scratch, they might see as more challenging than just going out and buying something that at least is giving them a good warning about future failures. So that is certainly one of the great opportunities for AI. If a company's in reactive maintenance right now, and they can benefit by being able to see the future. And what I mean by that, if there's a lot of reactive maintenance and every day there's another problem to deal with, sometimes getting a warning about what might happen next month, in 6 months or a year, it's like, you know, what am I going to do with that information? I'm having trouble dealing with the problems I have today and for the rest of this week. So industry reliability 1.0. Reliability 2.0, you know, is the combination of preventive maintenance and the use of condition monitoring. So, you know, a lot of companies switch to that time-based or interval-based maintenance and using condition monitoring to provide a warning. It's not necessarily a full maintenance strategy, but hey, it's a warning. But they get to hopefully see the problems coming and deal with them, or, you know, doing time-based maintenance, which certainly has its flaws as well. You know, reliability 3.0, I would say, is the sort of the traditional approach up until now, where it's condition-based maintenance, hopefully with a proper strategy, and hopefully doing some of the other things, you know, improving lubrication, aligning machines, balancing machines. It's a whole lot better than nothing for sure. But I would say that reliability 4.0 just steps that up a big step. And I'm going to describe, you know, how you would do that in just a moment. But there should be a much greater proactive defect elimination strategy going on, understanding all the root causes of failure and eliminating them, you know, making changes to avoid the reasons why equipment fails in the first place, where that is at all possible. So, you know, ideally, we want the bearings and all the other components out there just to be happy and be spinning away saying, I'm loving this lubrication, I'm not stressed. The people that start me and stop me, they're doing a good job. I'm happy, happy, happy. And they keep running. You know, if you look at the potential life of rolling element bearings and a lot of other components, you know, it's a long, long, long time. And a lot of organizations don't achieve anywhere near that life. So that's what we want to aim for anyway. But you may be wondering, how would you do that? So what I'd like to do is tell you about a process that we've been developing, since about 2010, I think, is when I sort of started. Now, we've got a name for it, asset reliability transformation. What I want to tell you right now, what you're about to hear isn't some great sales pitch. We have training on it, yes, but there's a lot of free information, and what I'm going to, you know, Tommy held up some books a little earlier, very inexpensive. You know, it's costs you nothing to get those books and find out what this is all about if you're interested. And also now I'm going to explain some of these, what these little colorful things mean, which you can follow. You don't need to exactly follow our process if you like. But my observation so I got involved with condition monitoring back in 1984. Yes, that long ago. We were still riding horse and buggies around and we're dreaming about airplanes. You know, it's a long time ago. What I've seen over all those years is a lot of companies, one way or another, trying to improve reliability and failing to some degree or other. They failed because they just focused on one thing, like condition monitoring. They said, well, hey, that's good, we'll do that. And it is good, and you should do it. But it needs to be in combination with other things. You need good planning and scheduling. You need good spares management. You need a whole lot of things to go right, to do things well, for everything to work properly, for everyone to be on the same page, everyone making the right decisions. You know, no weak links in the chain, you might say. But what I found is that there's always focus in different areas. There will be people who will say, RCM, reliability-centered maintenance, is the answer. Oh, it's the answer. RCM, RCM, RCM. And it's like, it's part of the answer. It's not the answer. There's others who will talk endlessly and want you to spend huge amounts on spares management. Or there'll be a huge focus on planning and scheduling. I mean, there are books and training courses where the message is, hey, planning and scheduling is the answer to your problems. It's one of the answers to your problems. There's others, root cause failure analysis. Oh, do root cause failure analysis. It'll solve everything. It's one of the answers. So my goal with what I'm about to talk to you about is, how do you incorporate all of these things together in a way that allows you to get all those things right? Because the other thing that I see is, someone attends a session like this, or a conference or whatever, and they hear about RCM, for example, they say, right, we've got to do that. And they kind of put all their eggs in that basket. They have all their hopes in developing this great maintenance strategy with RCM. And they end up with this great big thick document. These are all the things you must do. And it sits on a shelf and gathers dust because you don't have all the other pieces in place. But then the question is, well, how do you do it? What should you do first, second, third, fourth? And that's the idea of this ART, Asset Reliability Transformation process. So, some of you may have just fallen off your chair. It's like, oh my goodness, look at all those things. We got to do all those things. Well, if we were to sit here long enough, I could go through and justify every single one of those things, and 3 times as many of those things that I haven't shown. Well, maybe not that many, but there's just a lot of things you have to do. None of it's rocket science. But you have to do it in the right order to get the right foundation in place, to get things under control, et cetera, and I'll talk more about that in just a moment. Again, I personally feel that the world of reliability has done an injustice on a lot of people in the industry, sort of setting them up for failure, saying you must do this and focus in this area. And people get frustrated and disappointed, and their programs, they will see improvements, but often it's this cycle of reliability. They have some success, somebody leaves, management decide, this isn't working, and they fire some people, and it goes down. They have a few more failures. Oh, here, we need to do some more. And it goes up and down, up and down. Condition monitoring comes and goes. Root cause analysis comes and goes. Lots of root cause analysis projects are started but never finished. And anyway, you've got to break out of that cycle. You just got to. So I should say, with this process, we have, you can see there's actually 10 of those little blocks there, 10 phases. We have 64 steps and 360 individual, what we call recommended practices, that we say, do all these things in this order and you will have happiness for the rest of your life. I'm just joking there, but well, if you had a reliable plant and you were responsible for it, then you would be happy. Anyway, let's start at the start. Number one, you must understand the value of this proposition. It all starts with the business case. No amount of talking about common sense and the logic of condition monitoring or any of these other things makes sense to management. Management want business results. They want happy customers. They want regulators happy, profits. And so if you start talking about vibration or any of those technical terms we've gone through, they go, what are you talking about? And how does that make me achieve my goals? Well, we have to translate that to their language. So the value phase is all about establishing a business case that says, what will reliability do for us? What will it do for our business? And if the business world changes because of pandemics or recessions or whatever it is, then maybe the goals of the business or the priorities of the business might change. And what you do, therefore, how you make your decisions, how you prioritize all of your activities needs to stem from that. And you need to constantly communicate those benefits over time. If you do not keep reminding senior management why you exist, there's a chance you won't exist in the future. Well, not at that company anyway. So we must prioritize everything we do and justify everything we do based on our business case. Whether you have already started this process and you have a good program, if you couldn't look a senior executive in the face and tell them why what you do adds value to the business, why you are indispensable, then you've got trouble. And I would suggest you go out there and answer that question. That's phase number one. And I should say all these things overlap, and it's not like you do everything in phase one before you move on to the next phase. The strategy phase is saying, okay, now we have senior management support, which is key to everything, because you won't change the culture without that support. You won't be able to make changes without that support, and so on. We then need a team in place. We need to create a plan and a strategy and decide all of the steps. As part of this, we do need to do some, develop a bit of a maintenance strategy and get organized. And so strategy is all about getting organized and deciding what the outcome is going to be and such. The third component, and potentially the most important, is the people side of things. And that is making sure that everyone understands what's in it for them if the plant is improved in terms of reliability, and they all need to understand how they can contribute to that process. Now, with all of these things I'm saying, I mean, they're big statements, they're big subjects. You might be asking, how do you do that? How do you do that? How do you do that? Well, that's why there's so many steps in the ART process, to tell you how. And it'll be different for each of you in different industries, but the guidance tells you how to do it for you. You can figure it out. But with senior management, we can change the culture, but we need to be creating awareness training and getting people all on the same page, so everyone's pulling together and going in the same direction. Now, this control phase, I like to call it breaking out of the reactive maintenance cycle of doom. There are a lot of organizations that sort of shoot for this gold standard of reliability and asset management. Oh, ISO 55000. Yes, we must do that. And standing in their way is this great big barrier called reactive maintenance. And so many people have said, right, we're going to do all these wonderful things just as soon as the machines stop failing. So I've actually got some time to make those changes, and the machines don't cooperate and keep failing. So we need to break out of the reactive maintenance cycle of doom to have any success. Now, if you can still see the faint diagram in the background, you can see there's like these foundational elements I've just been through, and then this sort of cycle. This cycle inside here I call the cycle of reliability, but the start of the asset's life comes from the acquire phase, which I briefly mentioned earlier, and that is, we don't want to import trouble into our plant. Now, you might have to, or you no doubt have to deal with the problems that have been created in the past, but certainly from now on, you can say, we need to change the way we make decisions, and we need to change the quality assurance, quality control process, so that in the future, our life cycle costs will be lower. We will achieve better results if we can just make better decisions. That's yet another reason why you need senior management support. You need to say, I know we've got to invest a lot of money, but I'm going to get you to invest a little bit more, because over the life cycle of this project or of the site, you will reap the rewards. Now, unless they understand the business case, they're going to be going, oh no, it's all about what the next balance sheet looks like, and you'll be back to square one. They must understand the economics of all of this. So once we have, made changes in the way we acquire and purchase equipment, and that also goes for all the service work you have done, motor rewinds, gearbox overhauls, etc., etc. We only want good quality items coming into our plant. Then we get into the cycle of reliability within the company. Everything must be done with discipline, Everything in the maintenance group. Imagine for a moment that you worked at an airline or you made aircraft. Everyone should hopefully know the consequences of getting something wrong, and therefore everyone knows how to do things correctly. There are procedures, there are workflows, there are checks and balances, there are standards that must be met, and so on. Now, I'm not saying that every industry, therefore, has to mimic what they do in the airline industry, but there's no doubt that discipline is key. If everyone's wandering off doing whatever work they want, whenever they want it, they're doing jobs any old way, etc., well, you'll have the problems that you have today, assuming you do. So we must establish that there's one way to do everything and everyone does it that one way. We must care for the assets. So the acquire sets us up for success, discipline sets us up for success, and now when the equipment is operating, we care for it, keeping it clean, lubricated, bolts tightened, PID loops optimized, the operating process all optimized so that the equipment's it's running well, and it keeps running well because we're not stressing it and contaminating it and everything else. Now, the analytics phase is all about making data-driven decisions. So everything we talked about earlier, artificial intelligence, machine learning, condition monitoring, that and other things fit into this area where rather than making decisions because it sort of makes sense, and I think I read that somewhere, we are making data-driven decisions. Condition monitoring and condition-based maintenance is a data-driven decision. Prioritizing based on asset criticality ranking is a data-driven decision. I could go through lots of other examples of that, but if we know what's important, we can get the data and help us make decisions and make improvements. At some point, the asset will either fail or it'll reach the end of its life, or we might have near misses where something happens, we're lucky there wasn't an injury or something. The point is, and it's kind of part of the analytics phase, but it's all about learning from those failures of performance or failures of the equipment and not repeating the same mistakes in the future. It's what can we learn from this episode so we don't repeat it. So this end of life, sorry, that's what EOL is, end of life phase, is related to analytics so that we can make data-driven decisions. It's also related to the optimize phase, and it's kind of related to plan, do, check, act. But I like to say you do everything with discipline, you care for your assets, you make data-driven decisions, and then you optimize everything you do. In the discipline and care phase, we're doing what we believe is the right thing to do. But in the optimize phase, we're going to ask, is there a better way? Is the data telling us we should do things differently? Are we in a pandemic now? Is there a recession? Has the oil price gone up? Has the oil price gone down? Do we have new competitors, or have we just bought our competitors? We need to do everything to add value. And that's what the optimize phase is about. Continually asking the question, is everything we're doing adding value? Is there a better way we can do things? So that's the ART process. It's, as I mentioned earlier, there is a lot of detail behind it. There's, one of the books that Tommy held up sort of summarizes all of that. There are other books that go into some of the details of it. For what it's worth, for your own professional development, a lot of people these days are asking, what is the future of condition monitoring? And, if artificial intelligence is coming, should I still be a skilled vibration analyst? Well, I would say there's never been a better time to improve your skills. You've got to be better or smarter than the artificial intelligence system, if I can put it that way. So the artificial intelligence system with industrial Internet of Things, wireless sensors and so on, it might collect the data. It might even screen the data, as in, from all the measurements taken, identify that these are the small number that show some sort of change and may even indicate a certain type of problem. You need to be smarter than it so that you can then analyze the data and say, aha, this is either the artificial intelligence system is correct, or I'm going to do some troubleshooting. I'm going to do some extra tests to find out what's really going on with this machine and what action we need to take as a result. Use artificial intelligence and machine learning what it's good for, that bulk work, and then leave the humans, you do what you're best at doing. The other side of it is we have a program called Asset Reliability Practitioner. And the idea is it recognizes that well, the way we put it, there's kind of 3 different types of people in the reliability world. So we have a course, ARP-A, for Reliability Advocate, which just provides good general knowledge about, well, everything in that ART process. It's just a really good introduction to all those things to make people, you know, aware of how all these issues are intertwined, how to run a program, and maybe how to breathe new life into an existing program. But where it gets interesting or more detailed, ARP-E for Reliability Engineer is very technical. The idea is that there should be at least one reliability engineer who understands the technical side of all of what I just described. Reliability analysis, condition monitoring, precision maintenance, root cause failure analysis, RCM, all those, you know, all those areas. Someone must support the program leader with the technical expertise to make sure everything is being done correctly. And so that's very much on the sort of the maintenance and reliability side. And then there's the ARP-L for the business case, the implementation, the culture change. It's the management of the program, bringing everyone together, keeping management on side, getting everyone within the organization on side. And that is very much about the ART process, you know, how to implement that. So I apologize if it sort of sounds like a sales pitch or whatever, but, you know, if you're interested in what we've talked about so far, this is one way you can learn more about it and sort of get up to speed so that you can take on some of these challenges. So, final conclusions. Artificial intelligence and machine learning and so on, it is coming. It's here right now. There are systems already in place. There are companies already developed products. It is necessary, I believe, for anyone involved with maintenance, reliability, asset management, and condition monitoring to understand the strengths and weaknesses. There are many strengths, there are many weaknesses, and there are lots of organizations falling into traps right now. Just one of them is the fact that there are lots of companies right now selling sensors using MEMS technology, MEMS sensors, and they are not fit for purpose. They cannot cope. They cannot detect the higher frequencies. They get overloaded very easily. There's other issues. So that's just one of the issues that people in your line of work need to properly understand. Next, there needs to be a focus on improving reliability. You know, we can utilize AI for what it's good for, but improve reliability so that the organization achieves the best results. We must always be asking the question, you know, how am I adding value? What am I doing for the organization? You know, how am I prioritizing the work I do on the various assets in the plant to achieve the best results for the business? If you're doing that and you're communicating the benefits of what you're doing, management will love you, promote you, keep you, and not, sadly, what we see in this industry all too often is management just saying, we don't seem to have as many failures and these people are costing us money, so let's disband the reliability group. I don't know how common that is in Norway. I do know it's common in many other parts of the world. So I hope you found that presentation, well, either interesting or useful, and hopefully both. And I think now, if there are any questions, Tommy's ready to relay them on.
Now,
any question is fine.
Yes, I see there is one question there from Per.
Yes. Hello, Jason. I think I met you sometimes in EFMNS, and it was a very good.
Oh, right, yes.
Good presentation. And in Norway, we are using availability sometimes instead of reliability. And also in IEC, they are also using the word or concept dependability. Can you
Yes.
give us a more explanation of why are you using reliability? Is this a better word for you than availability?
You know, it's a really good question, and it is frustrating because when people look for standards on reliability, they don't necessarily find them because, as you say, there are lots of standards related to dependability. And one problem with the word reliability, it doesn't necessarily send the right message to people. You know, people can think about reliability in terms of their car. Is it reliable? And you know, and as I even said right at the beginning, you know, are we talking about the whole plant and its reliability or dependability, or are we talking about the physical asset? So it is always important, I guess, with whom you are communicating with to explain the difference. Part of the problem with the word reliability is you can boil it down to the very technical term of, you know, what's the likelihood of it starting when you need it to operate? You know, will it operate when you need it to operate? You know, we can look at the definition of reliability, of availability, you know, over a period of time, you know, how much of that time was it available to operate? And then, you know, dependability. My understanding is they used that term, they chose to use that term to avoid confusion with other definitions of reliability. That's my understanding. But yes, so as you can see, I've and many others have chosen to use the word reliability, and certainly, you know, I don't hear people using the word dependability that often when talking about these sorts of topics, even though, as I say, there's those European standards that use that term.
I totally agree with you with your explanation, and I think dependability, this word was reborn in IEC standards under Technical Committee 56 dependability.
Yes, I agree. And I know that because I'm involved in the ISO standards, but on the condition monitoring committee, and there's been talk at our level to say, you know, should we try to encourage them to change that word? But of course, you know, it's very difficult to do that, and people ask whether it's even appropriate to change it. So it does create a bit of confusion, and there's enough confusion around the word reliability anyway. For me, I would also say that even though I talk about the reliability transformation and all of that, a little earlier I was talking about the value phase, and I would say that if you're talking to business people, everything needs to be translated to the language that they speak. And so depending on the nature of the business, it's all about customer satisfaction, profit, you know, production output, you know, more tons of product out the door, you know, and happens to be that reliability and condition monitoring and all these other things are the way we achieve it. But, you know, you can say, well, this is what we are hoping to achieve. If you want to know the details, you know, you can then tell them how. I guess the other thing we should say is the term asset management, of course, has become famous in more recent time. But if you Google asset management, you'll get, you know, financial asset management and, you know, lots of other things. So I don't know whether they helped or sort of hindered the process by using that phrase, but it is what it is.
Yeah, thanks a lot.
Pleasure.
I have also a comment there. I saw you mentioned reliability 4.0. Interesting. We call it digital reliability, just because in the last couple of years when we're talking about machine learning, artificial intelligence, and so on, also it's digital journey to say. So therefore we are focused, well, a traditional condition monitoring program is to detect problems. The more problems, bearing faults and so on you detect, the more successful you are. What is better than detecting the problem? Avoiding the problems. That's where the reliability concept comes in. And there are so many things we can do with our computers, with the algorithms, and so on, to actually identify problems, root cause, and so on. We need to get the data in there and work on the data to improve reliability. We don't need to make all these artificial software for detecting the problems, because that's not the biggest job we have in our maintenance world. Achieving higher reliability is a much bigger task, and that's where the focus should be. So your reliability 4.0 things combine very well with what we call digital reliability.
Yeah, and for what it's worth, not to sort of be nitpicky, as we would say here, the only issue or concern I would have with the phrase digital reliability is that it potentially puts an emphasis on the digital side of it, whereas there's sort of so much, it's a very important part of it, but there are other things that we need to also focus on, or you know, all the culture change and so on that needs to happen, because no amount of technology can change the way a person behaves. I mean, unless you're bypassing them, or unless you're forcing them or checking them, you know, we need to change behaviors, and that's in culture change, and get everyone sort of, I guess, you know, working together. But there certainly needs to be more of a focus on it all to avoid those problems, and hopefully also to create, you know, one good thing about having automated anomaly detection and data collection, potentially condition monitoring people will have more time to focus on the root causes. They will have perhaps better data to look back on, rather than measurements every 30 days or 40 days or 60 days or something. They'll have much better data to see how problems developed, and then use that to identify the root cause, and then hopefully have the culture and the mindset and the time and resources to change the root cause, so eliminate that root cause. But yeah, definitely take your point. Yeah,
and then I agree also that reliability 4.0 is maybe better than the digital reliability. So thank you for that. Yes. Any other questions?
Does anyone disagree with something that I said? Maybe you can ask Tommy anonymously if you prefer.
There is a question. Let me see.
Hello, my name is Dmitry Ivanov. ConocoPhillips is a reliability engineer for 10 plus years, actually, with smart signal mostly as anomaly recognition. I guess you know that name. I must add, just say I completely agree with Jason. And we have all the issues you listed here in the company, from people who need to change their mindset because they are even more years in the industry than you, Jason, and so on and so on and so on. Also, huge challenge here is the data quality. Because, yeah, we invest a lot into smart instrumentation, all that stuff, but when it comes to somebody is not patching the server right, and then I lose like 1 month of data, not much I can do about it.
Right.
But I don't have any questions to you right now. I just wanted to say thank you for the presentation, and also thank you for the great YouTube video.
Oh, good. Well, thank you. Thank you very much. And you know, it just sort of echoes that point that unless people really understand how they benefit and how they can contribute, you know, there's that old thing of, you know, no one likes change. I think people are okay with change if they contribute to the change. So rather than people trying to change them and tell them, you must do this differently. I know you've done something the same way for 30, 40, 50 years. We need you to do it differently. If instead you can communicate with them, educate them, but then basically say, well, we want suggestions from you, and would you like to take ownership in the process? And so rather than the reliability team being this big with just a few people, you can look at many of the employees all being part of the reliability team. They can all come up with ideas. They can all take some ownership. And we're not talking about having, you know, an operator redesign a piece of equipment, but there are so many areas of waste, frustration, contamination issues, all sorts of things that can be improved upon And also those same people often observe problems, and they might have even made suggestions once. Why don't we change this? Why don't we do this differently? But probably someone stood there with their arms closed. No, we're not changing anything, and I'm not listening to your idea. I'm not acting on your idea. And that's just demoralizing. And people say, oh, well, I'm not going to make suggestions for improvement anymore. So yeah, it's if we can just get people on board and get them contributing, then they're part of something new and important. They see more safety, more job security, hopefully more job enjoyment, because they're part of the improvement process, not a victim of it, if you like. So
yeah, some people see themselves as victims, actually, especially those in time-based maintenance.
Well, yeah, they feel threatened. They say, well, you know, you want to do things differently, but if my job is to do this and you want to make changes, what happens to my job? And does that mean that what I've been doing for years has been wrong? You know, it takes some diplomacy to, you know, educate people and to help them come to the conclusion themselves that, okay, some things we've done all these years is good, some things need to change, need to be improved. But the more they can identify those opportunities by themselves, then it's not your solution that they're implementing, it's their own solution, and they can take ownership of it and be rewarded for it. And where companies have done that sort of thing, it makes such a huge difference. But you have to sometimes let go of control to let people do these things in order to see these sorts of improvements.
Thank you.
My pleasure.
Anyone else want to share some input or questions before we round it all up? Nils Martin Rugsveen, are you still with us? It'd be interesting to hear from you and your points.
Yeah, I'm still here. I was just about to leave because I'm on my way into another meeting. So,
sorry.
But thank you, Jason. It's been very interesting, and I share many of your thoughts here, and I hope that in the future we will be able to efficiently introduce your thoughts in our reliability management, because we are still prone to fall into some of the pits that you have been describing. So it's a difficult task in a large organization.
Yeah, it is a difficult task, and it's something that's not going to happen overnight for sure. But I guess that's why I try to create a lot of detail about all the steps and try to explain them all, just to, you know, I think it's possible to be overwhelmed sometimes, to think, gosh, so many people have been doing things a certain way. People like me on a presentation like this say we got to do this and this and this and this and this, and you know, I can imagine at the end of a call like this feeling exhausted, thinking, oh my goodness, look at all those things we have to do. The idea of all these little steps is so that you can say, well, let's not look at the end goal and be overwhelmed and concerned about how long that might take. If we just focus on the next thing we have to do and feel some level of success that we've done that, and then you can do the next thing, and then you can do the next thing, and it's like, we're moving. You know, we are making change. I think, you know, when people just look at the big picture, you know, it's very hard to measure success if it's like, wow, we have to do this huge thing or see these major results. And it's very hard. We're all humans, and you know, no one likes that feeling, and particularly if things don't go well. So
yeah, that's right. Well, anyway, thank you. I'm sorry, I will have to leave now. But it's been great.
No.
Okay.
Excellent. Thank you.
Well, then I think it's time to wrap it up. Thank you so much, Jason, for inspiring us, and many thanks also to everyone who participated. You will find the recording on nfv.no later today. If there is something you think NFV may help you with, do not hesitate to get in touch. Have a nice dinner, Jason, and have a nice day to the Norwegians. Thank you so much.
Okay.
Bye.
Bye.
Bye-bye.